Good afternoon. Today we are looking at adding and subtracting sig figs. Let's make that nice and big. All right, for anyone who is wondering, this is on page 15 of the Unit 2 data booklet. Okay, and before we go on with adding and subtracting, you have to remember what the definition of significant figures is, and significant figures are used for measurements. Okay, they're used for measurements. Remember, your exact numbers have infinite sig figs, but in a measurement, it includes all the certain digits plus only one uncertain digit. And I'm going to try and color code my certain digits in blue during our time here today, and I'm going to color our uncertain digit red. Now, if we take our measurements and we do a calculation, like let's say we're finding area and we take distance A and we multiply it by distance B, any number that we calculate from those measurements can also include only one uncertain digit. So it's going to be all the certain digits plus one uncertain digit. Or if you took two length measurements and you added them together, you couldn't, have it be more precise than your less precise measuring device. We'll edit that out because that made no sense. Okay, so we are going to take a look here. We have ruler B, and we're going to measure that. So we have 0 centimeters, 1 centimeter, 2 centimeters, 3 centimeters. So this is 3 point something. So I'm going to say this is 3. Oh, and I said I would color code, so let's color code. So this is 3 point, and I can't know for sure that that's a 2. I'm going to guess that it's a 2. So I'm going to put my uncertain digit in red. Okay, so that's 3.2, and then I have to include my unit. Don't forget that on your test if you're writing a measurement. 3.2 centimeters. Now we're going to look at the length of object C. And in this case, we have 1, 2, 3, 4, and it's just, to me, it looks like it's just before the 5 centimeter mark. But for the purposes of this, I'm going to assume that, I was just looking at it and it looked like it was right at 5. So let's say I thought it was 5 centimeters. Now, is this 5.0 or is it 5.00 centimeters? Pause the video for a moment and answer that for yourself. Is it 5.0 or 5.00? Well, if you were to have looked at this as 4.9 instead of 5, you could say, okay, I think it's 4.9. It's not actually 4.9. 4.9 would be right here. Do you see the little red mark? And we're actually closer to the 5. It would be 4.99. Okay, and so the length of object C is going to be 5.0, and my uncertain digit is going to be the 0. Okay, because I'm certain that it's 5.0. I don't think maybe, oh, could it be 5.1? What do you think? Could it be 5.1? No, that's way, way, way too far away. Okay, so that measurement has to be 5.00 centimeters. And so we have a measurement of 3.2 centimeters and a measurement of 5.00 centimeters. And now we're going to say, what is the combined length of objects B and C together? So I'm going to make this smaller so that we can see both objects B and C. So our combined length will be, I'm going to take my 3.2 centimeters, and I do have to put my units, centimeters, and I'm going to add my 5.00 centimeters, 5.00 centimeters, and when we do that, we get 8.2. If I was just to do it on a calculator, the calculator would spit out 8.2. Now let's ask ourselves, are we certain about the 1's position? Well, the 1 was blue and the 5 were blue, so yeah, I'm sure about the 1's position. So I'm actually going to replace that with a blue 8. Maybe I'll erase and then do that. Okay, so that's going to be 8. And then I have to ask myself, am I sure about the 2? Well, if I look here, my 2 is red, so that is uncertain. And even though my 0 here is certain, if I'm uncertain about the 2, that makes this digit uncertain. So what we're going to do is we are going to say that our 2 is our uncertain digit. Our 2 is our uncertain digit. And so we're just going to leave it as that. Okay. Now what if I had actually done this as 3.2? Oh, and I forgot my centimeters here. Don't forget that. Centimeters. 3.2 plus 4.99. Where is it? La la la. There we go. 4.99. And in this case, I'm going to be a little bit lazy and I'm going to put my centimeters on the outside of the brackets. That's the other way I can put centimeters. I can either put it both places or I can put it just at the end there. Okay. And I'm going to write my answer. I'm just going to write my answer here, and that's going to equal 8.19 centimeters. Okay. Now I'm going to underline or box or highlight. In this case, I'm going to box my uncertain digit, which is the 10ths position. And I'm going to box my uncertain digit, which is the 100ths position. So my largest uncertain digit, is the 10ths position. Okay, the 0.0, no, not 0.01, the 0.1 position. And we get that from the 2 here. That's uncertain. So this is our uncertain digit. So if this were the answer that I got on my calculator, I would say I cannot leave this as 8.1 centimeters because, or sorry, 8.19 centimeters because I can't have any digits past my uncertain digit. So I will actually have to round this so it becomes 8.2 centimeters. Okay, so that is what that looks like. And the moral of the story is that when you are adding and subtracting in sig figs, you are going to round your answer to the first uncertain digit, and that would be your largest uncertain digit. In the last question, it was the 10ths position, not the 100ths position. Okay. This will ensure that you have only one uncertain digit because remember, you cannot have more than one uncertain digit to have correct sig figs. Okay, let's look at our rocks here. We've got two different balances, okay? This balance on the left goes to the, like if I looked at it with nothing on it, it would read 0.0 grams. Okay, and this one on the right, I don't even know how it would read because quite frankly, it doesn't look like it's doing much of anything. It looks like a terrible balance. It looks like it measures to the tens position maybe? I don't even know. This is crazy. Okay. Oh, and it looks like my rocks are different too. I've got a littler rock here and I've got a bigger rock here. Okay. So let's look at putting the rock on balance A. Well, what's going to happen is that that last digit of the balance is going to flicker. So you see here it was 0.0, here it's 0.1, 43.1, 143.1. And here it's, oh, look, it's 142.9. Okay, so our uncertain digit would be what position? Pause the video and answer. What would your uncertain digit be on balance A? And remember, this is the same measurement all through. It's just that, you know, the balance sits there and it wavers between those numbers. It's like, oh, 1 second it says 143.0. The next second it says 143.1. The next second it says 142.9. Hopefully, you answered that your uncertain digit is in the tenths position, the 0.1 position. Okay? So how should we record the mass of rock A? Well, if we look at all our values, we have 143.0, 143.0, we have 143.1, and we have 142.9. And if those are the numbers it's flickering between, I'm going to pick the one that's closest to the middle. And so I'm going to pick 130. So that's going to be, or sorry, 143. 143.0. And don't forget, you must have your unit, grams. Now let's look at rock B. Remember, for rock B, on scale B, it weighs 180 grams. Oh, and then it flickers. Okay, it's the same rock. We haven't changed anything. It's just that, you know, it flickers between the two measurements. It says 190 grams, and it says 200 grams. So it's going back and forth in between all of these three. So when you look at rock B, how would you record your measurement? Well, you would say, I have, for rock B, I have 180, I have 190, whoops, sorry about that, and I have 200 grams. So I'm going to pick the one that's in the middle. So I have 100, and oh my gosh, look, this is our uncertain digit right here because it's flipping around between the 8, the 9, and then rounding up to 20, okay, or 200 rather. So I'm going to say that we have, get rid of that, 190. Okay, so my uncertain digit is the 9 in that measurement. So it's 190 grams where the 9 is uncertain. On my previous balance, it was a much more precise balance. It could go to way more decimal places. My tenths position was my uncertain digit. So now we're going to add these two. And in this case, I'm going to actually show my work a little bit of a different way. Okay, I'm going to actually line these up vertically. So I'm going to write 143.0, and then I'm going to write 190. Okay, and I'm going to make sure that even though there's not a decimal place here, and I don't want to write one, otherwise I would have more sig figs, I want to make sure my decimal places line up when I write my work vertically. So now when I add them, I get 333.0. So 300, and oh look, this digit here is uncertain. So this 3, because it's made of combining the 4 with the 9, that will be uncertain because the 9 was uncertain. So that's 333.0. But you'll notice we have our uncertain digit right there. And that's our largest uncertain digit. It's in the tens position, and we can have only one uncertain digit. So our answer then has to round to that digit right there. So that would then be 330. And that would be grams, because the 3, that second 3 is our uncertain digit. One thing that sometimes people like to do is when they're doing it vertically, they like to draw a line right after their first uncertain digit that they come to. The only thing is I find that sometimes when people do that, they think, oh, I'm cutting off my number. So they'll see the 333 and 0.0, and then they'll see the line and they'll cut it off, and then they'll then round this to 33 grams. And of course you don't want that because 333 is certainly not equal to 33. Okay. So if you don't want to do it vertically, you're just going to follow the following steps. You're going to either underline or circle or highlight the uncertain digit in each number. You're going to do the math. You can do it in your head. You can do it on a calculator. Doesn't matter to me. And then you are going to circle or highlight the uncertain digits in the answer. And if in the question, right, if in the question you had it in the tenths position and in the other number it was in the 100ths position, then you would highlight here in your answer both the tenths position and the hundredths position. Okay, so you might have 3 point, different pen. So you might have 4.6, and you might be adding to it 5.18. And if you add those two, what you have to do first is you have to highlight the uncertain digits. So that's our last digit in each of those measurements. And your answer, you're going to calculate your answer. So do the math. So that's going to be 9.78. And then you're going to highlight your uncertain digits. Well, this 6 makes the tenths position uncertain, and the 8 makes the hundredths position uncertain. But we can only have one uncertain digit, so we have to round to that first or largest uncertain digit, and that is going to be, that would be 9.78. Okay, so round your answer to the first or largest uncertain digit. Let us try a few more examples. Okay. I have this here, and that looks like something where, oh my gosh, I don't want to do that. So I just plug it into my calculator, and my calculator spits out the number 45.251. Okay. Now, I look at it and I say, I have in my hundredths position, I have some uncertainty. So in my hundredths position, I have uncertainty. In the thousandths position, the third decimal place over, I also have uncertainty. How many uncertain digits can I have in order to have the correct sig figs? I can only have one uncertain digit. So I'm going to have to then round that to that hundredths position. So that's going to be 45.25. Okay, let's take a look at this next one. We have 9. Oh my gosh, there's only one number there. That means that digit is uncertain. And then in our next number, the third decimal position, the thousandths position, is our uncertain digit. We plug that into the calculator and we get 541.629. Now, according to this, my 9 makes the ones position uncertain, right? Because 9 is in the ones position. And this second 9 makes our thousandths position uncertain. So I've highlighted my uncertain digits, and then I say I can only have one uncertain digit, so I have to round to there, and we get 542. And that's your answer. Next, we have 347.1 minus 346.37. So my uncertain digit is in the tenths position, and then this one is in the hundredths position. What's my largest uncertain digit? It's going to be the tenths as opposed to the hundredths. Okay, so plug that into my calculator. I do the subtraction, and I get 0.73. Okay, and I say, oh, look, my largest uncertain digit is in the tenths position. Okay, that's my largest uncertain digit. So I have to now round to the tenths. Round here. Okay, so that's going to then become 0.7. Or you could express this as 7 times 10 to the negative 1. Okay, so interestingly, when you start learning multiplication and division, usually people tend to forget about the addition and subtraction rule. They are very, very different. So if you look at this, we are actually starting here. This number here has 4 sig figs. This number here has 1, 2, 3, 4, 5 sig figs, but our answer has only 1 sig fig. Okay, so the number of sig figs is irrelevant to the number of sig figs in your final answer. The number of sig figs in the question is irrelevant to the number of sig figs in the final answer. It is the uncertain digit that determines how many sig figs are in your final answer. Let's just go back and look at the last one. We had 1 sig fig in the 9. 1 sig fig. We had, oh my gosh, how many sig figs here? We had 1, 2, 3, 4, 5, 6 sig figs there, and our answer ended up having only 3 sig figs. Okay, and it just all depends on where your largest uncertain digit is. Okay, let's do a couple more. These are the ones that if you learned a different way of doing this in physics where they said the least number of decimal places, that works most of the time. However, let's look at this one. 550. Okay, 550 has no decimal places. All right, 550 though, the uncertain digit is the 5. Remember, if we had wanted the uncertain digit to be the 0, we would have had to write it as 550 with a decimal there. But because there is no decimal, the 0 is not a significant figure. Okay? So our uncertain digit is in the tens position. And in our second number, the uncertain digit is in the thousandths position. Which of those is larger? Well, quite obviously it is this tens position. So we have to go over to our answer, and in our answer, our tens position is right here. Okay, so even though our thousandths is also uncertain, our first uncertain digit is the tens position. So when we round that, now we're going to have to look to the number to the right of the 6, and we are now going to have to round that, and we are going to get 570. And our uncertain digit will be right there. So our final answer will have 2 sig figs. Okay, 1 here, and then our uncertain digit here. Couple more just for fun. If you get it and you want to just go do the practice now, you can just go do the practice now. So you can just go down to the worksheet, which is right there. And if you need a helpful video, you can go and click on this link if you happen to have the document open, or you can type that in. I don't know why there's a space there. Is that an underscore? At any rate, if it doesn't work without the underscore, put an underscore right here. Okay, it looks like there is one, but I'm not sure. Okay. All right. So if you do want a couple more examples, let's take a look at this one here. We have 3.4447. Oh my gosh, that's the 10,000ths position. Okay, and we're going to compare that with our other uncertain digit, which is in the hundredths position. Which of those two is larger? Well, the hundredths position is larger. So when we look at our sig figs over here, we have uncertainty in the hundredths, we have uncertainty in the 10,000ths. So we cannot go past our first uncertain digit, because if we're not sure about the 7, how on earth could we, or the first 7, how on earth could we know anything about the 4, right? Like, how can you go past an uncertain digit? And so this would then become 0.6, and we will now round to the 7. Now remember, don't double round here. Don't be like, oh, the 7 rounds that to a 5, and then that rounds that to an 8. No, 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 no. Something 0.47 is closer to, well, no, this is what I did on Friday, and it was bad, so I'm just not gonna, we're gonna leave that alone. Okay. All right, one last example, and I will leave you. Here we go. We have 55,000. There is no decimal place, so remember, no, yes, maybe. So these are zeros on the right, so maybe they are certain, maybe they're not, and they are certain if there is a decimal. Oh, but there is no decimal there. So those are not certain digits, or those are not significant figures. So my significant figures are the 5 and the 5, so my uncertain digit is the second 5. And in 76.2, that one's easier, it's that one. So I have an uncertain digit in the thousands position, and I have an uncertain digit in the tenths position. The larger of those two, what? Why did I write 1 over 1,000? Silly, silly. That's not 1 over 1,000. That is the thousands position. Not the thousandths. Gosh, that's hard to say. That's the thousands position. Okay, so right there is our larger of the two uncertain digits. That's our first uncertain digit. So we are going to round to there, and we look at the number next door, and we say that's a 9, so that's going to round to a 5. Ooh, what happened there? That was crazy. Oh, come here. No. Erase. Why are you not erasing? You guys can see the eraser, right? Oh, well, I'm just going to rewrite it. 5. Oh, everything did erase. Good times. All right. So we're going to round to our first uncertain digit there, and that's going to become 555. And remember, it's not just 55, right? It doesn't round to 55 because this is many thousands. So you can't round many thousands to 55. It's 55,000. Okay, and that's it.